What you're looking at here are the base units that we use in SI units. We'll also talk a little bit about imperial units, but to discuss the base units, we'll just discuss them in base I. Okay, so here you have things like the meter, the kilogram, the second, things that you're probably pretty familiar with, and these have a definition that we can define, that we can test in the laboratory. You see all those definitions. A lot of them are not something you could just do, at your own house, but in a lab with different machines, you can actually calculate these based on what you have. The one that is not is the kilogram. Kilogram is actually just a chunk of platinum iridium alloy. And once we define that, a lot of the other things, kind of come out of that. Okay. So again, with the electricity, you've got the amp. Temperature, you got Kelvin, which is actually absolute temperature as opposed to Celsius. Of course, the 0 is freezing, 100 is boiling Celsius. That is how you could define that. Okay, but Kelvin is the absolute value. Okay, so anyway, these are the base units. You can have combined units, such as like a pound per square inch, right? Where you're combining, that would be a force as well as a area, right? And combine those together. Okay, when you do that in SI units, force is actually in newtons, which is actually a kilogram meter per second squared, and you don't need to worry about that. You'll learn all this in physics, right? Uh, Area is meters squared. Okay, so a newton per meter squared, we actually call that a Pascal, which is a form of pressure or stress that we might have. Okay, so, but you can always boil things back to their original base units, one of these units listed here. Every other unit is derived from one of these defined base units. Okay. Um, we also use a lot of prefixes. Okay, you probably recognize these prefixes from computers, right? Like a gigabyte is a billion bytes or close to a billion bytes, right? You've heard of like nanotechnology. Well, a nanometer is 10 to the negative 9 meters. That's a billionth of a meter, right? You're obviously familiar with like kilograms, kilometers, millimeters. These are just prefixes basically that tell you, based on that like scientific notation, where's the decimal point located, right? So like a micrometer is 10 to the minus 6 or 1 millionth of a meter, right? A megapascal is 1 million pascals, and different things of that nature. Okay, and I assume that many of you are familiar with these prefixes as we go through. Now, what I have here is conversion factors that'll go between different lengths, different pressures, different volumes, whatever it might be, as placed right here. So these are equivalencies. So for example, if I'm going to go from 1 centimeter to inches, 1 centimeter is 0.39 inches. Or I can say 1 inch is 2.54 centimeters. It depends which way you're heading to do that. But we have these equivalencies, and we're going to use these to our advantage to do some conversions, which I'm going to do right now. And the first one we're going to do is convert 20 feet to meter, or 250 feet to meters. So I go ahead and I write in here 250 feet, and I want to convert that to meters. So what I'm going to do is I'm going to go use this equivalency, okay, where I have 1 meter equals 3.28 feet. Okay, and what I'm going to do is, because they're equal to each other, I'm going to take a fraction of one over the other one, because if I divide anything, or I have a fraction of any number divided by an equivalent number, it's 1. And if I multiply any number by 1, it doesn't change that number. We'll just be changing the units. So again, what I'll come down here is I've got that 250. Now again, I know 3.28 feet in 1 meter. Okay, so I'm going to set up my fraction. Okay, and because my feet are in the numerator in my number, I want to make sure my feet are down here below and my meters are up here. And I'm going to say, okay, 1 meter equals 3.2808 feet. Okay, so when I do that, this feet divides with this feet, and I'm only left with meters. And again, I can do this because in this ratio, this has a value of 1, because 1 meter equals 3.28 feet. And if I take any number times 1, it doesn't change that number. But in the process of that, I do get to change the units. So essentially, I'm going to take 250 divided by 3.28, and I'm going to get 76.2 meters on that. And that's how we do conversions. Okay. Let's do the same thing here. I've got 70 miles per hour, and I want to convert that to meters per second. Okay. Well, the first thing I need to do, let's go get from miles to meters. So I go up here and I go into length and I recognize, oh, I don't have miles up here. Okay. But I know that there are 520 or 5,280 feet in every mile. So again, I'm going to take a fraction. I'm going to put miles down here and I'm going to put feet up here. And I know that 5,280 feet equals 1 mile. Now I have feet per hour. Now I can convert feet to meters just like I did before, where I have 3.2808 feet for every 1 meter. Okay, so now I have meters per hour, right? Miles cancel, feet cancels. Now I just need to convert hours to seconds. Okay, well, what I know is in every hour, I have 60 minutes. So this hour cancels with this hour, right? So because my hour was in the denominator originally, I want to put it in the numerator here to cancel them. And again, 1 hour equals 60 minutes, so I don't change anything. And then, of course, 1 minute has 60 seconds. So those minutes cancel. And what I'm left with here is meters per second. So I take this string of fractions, multiply 70 times 5280 divided by 3.28 divided by 60 divided by 60, and I get the value 31.3 meters per second. So that's how you can go from 70 miles per hour to meters, 31.3 meters per second. So you just keep setting up these fractions like you have there. Okay. Now let's go ahead and go from 14.7 psi, which is pounds per square inch, and let's go to megapascals. Okay, which first I'm going to go to newtons per meter squared. Okay, so pounds and newtons are forces. So I recognize that I have right here 1 pound force equals 4.4482 newtons. So I'll start with that one. Again, I want pounds on the bottom. So I go 1 pound, and then on the top I have 4.4482 newtons. So that pounds kills that pounds. Now I have newtons per square inch. Now I want to convert from inches into meters. Okay. So I come up here and I can go, well, I have inches into centimeters. So we'll do that. We'll go 1 inch equals 2.54 centimeters. Okay. So I will say, so I have 1 inch equals 2.54 centimeters. But now what you need to recognize is this is actually inches squared. So what I need to do is I need to square this as well as this. So rather than 2.54, it's actually 2.54 squared, so that I can get from inches squared to centimeters squared. Okay. And again, I said I wanted to get from pounds per square inch to newtons per meter. So now I need to convert from centimeters into meters. I don't want that equal sign yet. Okay. And what I know is I have 100 centimeters in every 1 meter. But of course, these are also squared because I have that squared value before. So that centimeter will kill that centimeter. So now what I'll have left is newtons per meter squared in doing this. When I do that calculation, I get 101,352, and again, that's newtons per square meter. Okay, this is what we call a Pascal. Okay, it's a measure of pressure. Okay, it's a newton per square meter. I want it in megapascals. Well, megapascals is millions of pascals. So essentially, I need to take the decimal point and move it 1, 2, 3, 4, 5, 6, because it's millions of pascals. So it's 10 to the minus 6 on this. So it'll go 0.101352 megapascals. So that's how we deal with converting, square values, as well as dealing with prefixes going from meters to centimeters and pascals to megapascals and things of that nature.